Okay, so what we're going to work on today is we are going to be working, we're still in DMA80, and we are going to look at the review quiz. So we're going to start, this will be part 1, and I'm going to go through each of the different questions and we'll see how to go about solving this. Okay, so we're just solving an equation. I believe this is section 5. We have the cubed root of negative 9x minus 2. The cubed root of negative 9x minus 2 is equal to the cubed root of negative 3x minus 8. Now, the concept that we're looking at here is in order to remove this index of 3 for a cubed root, all we have to do is take the entire unit that we have, and if we have an index of 3 and we raise it to the third power, automatically the negative 9x minus 2 comes out and there's no more radical. What we do to one side, we have to do to the other. So if we take the cube root of the right side, then what comes out is negative 3x minus 8. So it's really that simple. I know you look at it and you think it's going to be complicated. It's not. Whatever the index is, if it was an index of 5, you would raise it to the 5th power. When you do that, there is no more radical. So all I have to do now is solve for x. So I'm going to move my 3x to the left by adding it. And then I'm going to move the 2 to the right. I will also be adding it. So negative 9 plus 3 gives me a negative 6x. Negative 8 plus 2 gives me a negative 6. Then I'm going to divide both sides by the negative 6, which is here with the x. X is equal to negative divided by negative is a positive 1. Okay. Use the quadratic formula to solve the equation. So we have 4m squared plus 7m equals 7. 4m squared plus 7m equals 7. Okay, so we're going to do the quadratic equation. So the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4 times a times c. Everything is over 2 times a. That is a formula you'll need to know. It's not given to you when you take the test, so you do need to memorize that formula. This is the formula from section 8, I believe it is, right there at the end of DMA 80. The first thing I need to do is put this in the correct form of ax squared plus bx. Now the 7 has to move over, so it becomes minus 7 equals 0. What I'm going to do is identify my a is a 4, my b is a positive 7, my c is a negative 7. So as I use this formula, I have the opposite of b plus or minus b squared, which would be 7 squared minus 4. A is a 4. C is a negative 7. Everything is over 2 times A is a 4. So I'm plugging in the A, the B, the C where they are located here. Now, I have negative 7 at the front. 2 times 4 gives me 8. This part I'm going to do on the calculator, just what's up underneath. Do not type the square root symbol. We're just typing the 7 squared minus 4 times negative 7. So 7 squared minus 4 times negative 7. That's going to give us 161. If you remember, when we check to see if we can simplify a square root or a radical, let's go to our calculator to y equals. We're going to do 161, the radicand, divided by x, and raise it to the power of the index. Second table, we look in the second column, and we need to scroll down to see if there is a 1. Okay, a 1 should be here, but there is not a 1, so it's not a perfect square root. Then I'm going to let my eye start coming up to see if I can find a pair of whole numbers. I'm looking for the first pair of whole numbers. And the first pair of whole numbers is the 1 and the 161. Remember, the left column comes out, the right column stays under the radical. So if a 1 comes out, we just really don't need to write anything different. So for this one, my final answer is -7 plus or minus the square root of 161 over 8. It can't be reduced any further. But could I have reduced that? I would have done so. Okay, rationalize the denominator. This is the only one that I feel like is the complicated rationalizing. It's not hard, it's just tedious. So let me get this one written down. 3 square root 3, 3 square root 3 plus square root 6 over 6 square root 3 minus square root 6. Oh, wait a minute. I think I miscopied something on the top. Let me catch that. No, that's right. It's a 6. Okay. So we are rationalizing the denominator. So in this case, what we do is we multiply by the conjugate. The conjugate is the denominator, but the difference is where this is a minus, we're going to change it to a plus. And you're going to put the same thing on both the top and the bottom, okay? So let me put parentheses around these so it looks a little neater here. So we've got, in other words, we have a binomial in the top and we have a binomial in the bottom. So we're going to FOIL the top, we're going to FOIL the bottom, and then simplify. So the only tedious part is the foiling. So I'm going to put here, I'm going to put FOIL numerator. Okay, so that's what I'm going to do. I have 3 times 6. Let me get my calculator. Okay, so I have 3 times 6 is 18. Notice square root 3, square root 3. So that means a 3 comes out, and 18 times 3 is going to give us 54. That's the first. The outside is going to be a 3 square root 3 times 6 is 18. For the inside, we're going to have a plus 6, and square root of 6 and 3 is going to give us 18. At the end, we have a plus. We have a pair of 6s, so a 6 is going to come out. So now what I have is I'm going to combine 54 and 6. That's going to give me 60. Plus 3 plus 6 is 9, square root 18. I still need to simplify the square root of 18. So let's go to our calculator. We're going to do 18 divided by x squared, second table. I'm looking in this column, there's not a 1, but my first pair of whole numbers is 3 and 2. So that's going to become 3 square root 2. So what I have now for the numerator answer, I have 60 plus 3 times 9 is 27 square root 2. So that's my numerator. 60 plus 27 square root 2. I'm now going to FOIL my denominator. As I FOIL the denominator, it's the same process. Here I have 6 times 6 is going to give me 36. I have a pair of 3s, so the 3 is going to come out. 36 times 3 is 108. When I do my outside, I have 6 times 1 is 6. Square root of 3 times 6 is 18. In the middle, negative 1 times 6 is minus 1. 6 times 3 under the radical is 18. Negative and positive is a negative. And here, oh, wait a minute. That's not negative 1. Catch me, y'all. That's a negative 6, excuse me, square root 18. And then here, negative and positive is negative. We've got a pair of 6's, so the 6 comes out. Now, we're still going to combine the 108 minus 6, which is going to give us 102. And I want you to notice here we have a positive and a negative of the same. So the 6 square root 18 is going to cancel out. So there's no need in this situation to simplify because it does cancel. So here I've got 102. Now, what I can do is I can simplify. Let me make the note, simplify. If they all have a common factor. Simplify if there is a greatest common factor. Our numbers are 60, 27, and 102. So let's review how we find greatest common factors. On the calculator, I'm going to use math. I'm going to go to the right to number, and I'm going to come down to number 9, greatest common factor. I have a 60, comma, and I have a 27. So the greatest common factor for 60 and 27 is going to be a 3. My other number that I have is 102. So math, arrow right, number 9. I had the answer of 3, and my other number was 102. Okay, so 3 is our greatest common factor. So we're going to divide each term by 3. So the GCF is 3. So 60 divided by 3 would give us 20. 27 divided by 3 is 9, square root 2. And then we're going to take 102 divided by 3, and that gives us 34. So this would be our final answer. This is the only one that I feel like is the most tedious, most complicated one that you have on the test. It's just a simple foiling. You just have to keep up with all the steps of what you're foiling, when something comes out from under the radical, and you have to pay attention to simplifying. Okay, a division. So when we have a division like this, we're going to have, let's see, okay, so 30 minus 26i, let's go to a new page. 30 minus 26i over 2i. You're going to use your calculator. The one thing you need to remember to do is to put a parenthesis around the numerator and a parenthesis around the denominator. If you forget the parenthesis around both top and bottom, order of operations is going to be inaccurate. Okay, so let's do our parenthesis, 30 minus 26. Now to get the I, we do second, come down to the decimal key, there's your I. Close your parenthesis, parenthesis 2I, and our answer is negative 13 minus 15I. Okay, when you're here on the calculator, if you press the second and then come down to the decimal at the very bottom, you'll see a little I in blue up above. That puts the I on the screen, second and the decimal. Okay, use radical notation to write the expression 7x plus 3 raised to the 2/3. 7x plus 3 raised to the 2/3. And they want us to write radical notation. All we're going to do is write this in the form of a radical. So let me write the little notes like we'd had before. If you have a base raised to a power, and you're going to write it in the radical form, the base is the radicand, the numerator is the exponent, the denominator is going to be the index. So all I'm going to do is I'm going to write a radical, the 3, that's going to be my index. They gave us 7x plus 3. Now what is very important is, even though the 2 is the exponent, if I write it and leave it like I have it now, it will be wrong. What you have to remember is they have a parenthesis and you have to have the parenthesis because it is the whole unit that is raised to the second power. If we had the 2 without the parenthesis, it would think it's 7x plus 9. It would only square the number 3 rather than squaring the whole binomial, which would be FOILed and would end up being a trinomial. And that's it. That's the final answer. The answer is just the radical form of that expression. Okay, this is a problem. The souls live on a corner lot. Often the children cut across their lot to save walking distance. The diagram to the right represents the corner lot. The children's path is represented by a dashed line. Approximate the walking distance that is saved by cutting across the property instead of walking around the lot. Okay, so let me sketch the drawing. That was an x plus 3. That was 15, and I believe that was x. Let me just double check. 15x, x plus 3. Okay, so the way the problem is written, let me explain what they're wanting you to do. They're saying the children should walk along the sidewalk. The red is the sidewalk. So they should walk around the sidewalk. So that would be x plus 3. That's the part of where they should walk. Instead, what they do is they cut across the yard. So instead, the kids, I'm going to do that in green like grass, instead they cut across the yard. So when they cut across the yard, that diagonal is 15. What we're trying to calculate is how many feet are saved by cutting across the yard. So that's going to equals, and that'll give us our answer. So if they should walk this distance, but instead they cut across, we would subtract the 15 from whatever this is. Ultimately, that's what we're going to do. However, we have to figure out what is x equal to. So in order to figure out what x is, notice on this, if it's a corner lot, this is a 90-degree angle. So we are going to use the Pythagorean theorem, and we're going to reflect back to dma080 section 14 when we learn to solve problems using the calculator. We're going to use squared plus b squared equals c squared. We're going to use this to solve. My a is x squared. My b is the x plus 3 squared. And my c is the hypotenuse squared. If you recall, when we did this, we would type in the left side on y1, the right on y2. So let's go to our calculator and do so. So let's clear. We have x squared plus, and then we have x plus 3 squared. The right side of the equation, the length of that was 15 squared. Okay, so we type in y1, y2. We're going to press graph to view it. Now, let me represent the zooming that we need to do also. So, hang on. Let me go back because actually I have something left from graphing in a previous class. Let me get rid of that. Okay, so we do y1, y2. We press graph to view it. And then our zooming, if you recall, we start at zoom 6. If we don't see what we need, we do zoom 0. If we still don't see the intersection of lines, we do zoom 3, enter. Okay? Once we find the point of intersection, we then do second trace. We choose number 5, which is intersect, and we move the asterisk to that point of intersection. Press enter 3 times, and that gives us the answer for x. Okay, so let's go through those steps on the calculator. So this is our zoom 6. I don't see 2 lines, so let me now do zoom 0. I see 1 line, and here comes the second one. We cannot have a negative length, so it's okay that we don't see the intersection on the left. This is the point that we need. If I still couldn't see it, I would do zoom 3, enter, but I can see this just fine. Second trace, choose number 5, intersect. Hold the arrow to move the cursor up to the right. And it doesn't have to be precisely on it, it can be near it. Press enter 1, 2, 3 times. Once you see the word intersection, the x answer here is the answer for x, which is 9. So I found that x is equal to the number 9. So let's come back to the problem. Remember, they should walk here. This is 9. And they should walk here. This is 9 plus 3. So we've got 9 plus 9 plus 3. That's how far they should walk. 9 and 9 is 18, and 3 is 21. Instead, they cut across the yard. That's 15 feet. So 21 minus 15 means they're only saving 6 feet by cutting across the yard. So I would utilize what you learned from dma080 to apply the Pythagorean theorem and finding the point of intersection for this one. In psychology, it's been suggested the number S of nonsense syllables that a person can repeat consecutively depends on his or her IQ score, I, according to this equation. S equals 2 square root I minus 9. S equals 2 square root I minus 9. Use this relationship to estimate the IQ of a person who can repeat 14 nonsense syllables consecutively. So we are going to substitute the S with the number 14. What we are solving for is the letter I. So the first thing that we should recognize is if we're solving for I, we need to start with this 9 and move the 9 to the other side. Okay? So what we have is 14 plus 9 gives us 23 equals 2 square root I. To get the square root I along, we need to divide both sides by 2. And 23 divided by 2 gives me 11.5 is equal to the square root of I. Think back to that very first problem we did today with the cubed root. If we want to remove the radical, the index for square root is a 2. So if I raise it to the power of 2, the I will come out from under the radical. If I square this side, I also need to square the left side. So you're going to use your calculator. And we're going to do 11.5, and we're going to square it. And that's going to give us 132.25. 132.2, excuse me, 132.25. And if I come back to the problem, it tells me in parentheses, round to the nearest integer as needed. The nearest integer means the nearest whole number. So if I'm rounding to the ones place, this 2 is going to make that 2 stay the same. So the final answer that you're going to give is going to be 132. The square root of 4x minus 7, the square root of 4x minus 7 minus 2 equals, oh, excuse me, minus 1 equals 2. Minus 1 equals 2. Okay, so this is similar to the first question that we did. If we're solving for x, we're going to need to get rid of this radical. But before I can do anything, I need to take the 1 and move it to the other side of the equation. So we have the square root of 4x minus 7 equals 2 plus 1 gives us 3. Now, if we're trying to get the radical alone, the index here is a 2. So that means I'm going to raise it to the power of 2, which means the number 3 on the other side I'm also going to square. 4x minus 7 is now magically out from under the radical. 3 squared gives me 9. I'm going to move my 7 to the other side. 4x is equal to 9 plus 7 gives me 16. To get x alone, we're going to divide both sides by 4, and x is equal to 4. Square root of 3x equals negative 9. The square root of 3x equals negative 9. This one, I want you to work smart, not hard on this problem. Okay? Think back to when you have a square root of something, the big thing that we push and that we talk about is that you can't have a negative answer when you have an even index. And if it's the square root of something, the index is even, which means a negative 9. Anyway, if the answer under here, if it were negative 9, that would give you a positive. So there can't be technically a negative solution. An odd index can have negative answers, but not an even one. So for this particular problem, you're going to give no solution as your answer, because I want you to recognize square roots can't have a negative answer. And let's do one more. Oh, this is a real easy one. A ball is thrown downward from the top of a 100-foot building with an initial velocity of 29 feet per second. The height of the ball, h, after t seconds is given by this equation. H equals negative 16t squared. H equals negative 16t squared minus 29t plus 100. How long after the ball is thrown will it strike the ground? Okay, you don't need to worry about them wording the sentence because they gave you the equation. They want to know the height when it strikes the, how long will it take before it strikes the ground? So, how long before it strikes the ground? So that means, what is the height when something's on the ground? The height is going to be 0. On the calculator, we can't type in the letter T. It needs still the X's. So you're going to type it in with the X's. And what we're going to do is we are going to solve this just like we did DMA60 section 14. We're going to type this on Y1, this on Y2. And since I already wrote the notes on a previous slide, I'm going to just put find the intersection of lines. And remember, time cannot be negative. Okay, so let's come to our calculator. We're going to go to y equals. We've got a 0, and then we've got negative 16x squared minus 29x, well, excuse me, not squared, back up, minus 29, wait a minute, I'll have it there in a second. And then plus 100. So we're going to go to graph to view it. Now, at this particular scenario, we had done another problem, so I need to get back to the point of origin. So I'm going to start with zoom and number 6 to go back to the beginning view. This blue line that came across is the height of 0. The red line is our parabola. On the left side would be negative time, and we cannot go back in time, so we're going to find the intersection on the right. We're going to do second trace number 5. We're going to move our cursor to the right. Oh, wait a minute. And I'm hitting graph. Excuse me. There we go. Move the cursor to the right. And once we get it near, press enter 1, 2, 3 times until you see the word. Hang on. One more time. Let's try this again. Second trace 5. Okay. Move the cursor to the right. Because if it ever just doesn't, see, I didn't see the words, so something I knew was wrong. Enter 1, 2, 3 times. When you see the word intersection, we have 1.7529. 1.7529. So let's come back to the problem and see how they want me to round. Round to the nearest tenth. So that means with this problem, if I'm rounding to the nearest tenth, the 7 is in the tenths place. What does the 5 make the 7 do? It's going to round up with an answer of 1.8 seconds. So what I'm going to do for now is I'm going